Hi folks, let's use two tools to machine this Porsche 911 out of a piece of aluminum. Welcome to another Wednesday Widget. So we needed a part to run during our open house. I wanted something that would show off the 440, the 10,000 RPM spindle, its ability to kind of do nice 3D toolpaths, and something that ran for a couple hours so I could be off talking to folks and attendees. And we were working on the fuel cap project for the Porsche 930 Turbo, and I thought, I bet you there's a file on GrabCAD. So there's 3 websites that I really recommend you guys take a look at for CAD files. And if there are more that I'm not mentioning, please post them in the comments below. The first is GrabCAD. It's the one I used the most. And this black version here is the vehicle model that we downloaded and used. That's what's so cool. You don't have to do anything. And we'll go through at the end of this video the nitty gritty of actually downloading it for folks that want to see every little step. Very easy though. The other 2 sites, one is Thingiverse. I don't use Thingiverse. I think it was part of the 3D printing or MakerBot sort of team and movement. More pedestrian type stuff, but honestly I probably should take a look again because I bet you there's a good repository. And then lastly but not least, McMaster-Carr. We've talked about this on a ton of videos. When you search for many, not all, but many products on McMaster that has this little CAD sign right here, you can download the CAD file. You know, SolidWorks, Step, Print, I mean, amazing, folks. Just do not reinvent the wheel when you don't have to. GrabCAD is my favorite. There's a huge amount of information out there. I typed in engine just to show you. Here's a piston in SolidWorks. Here's a bar and Stroud engine in SolidWorks. It looks like an assembly. A header, a much better piston with a connecting rod. And folks, what's so cool is if you have SolidWorks, you can open this, and in Fusion 360, you can even import SolidWorks files. So just an awesome way to learn. There's some cool lessons, I think, though, to this, which is it's just so easy nowadays. We've been doing a lot of reminiscing lately with the Chip Break series, and I found an old presentation we did in 2010, and I love my story. I love the way we did it, but my God, I wish I had this machinery and knowledge and YouTube and Fusion 360 back when I started, because we're going to do 2 things. We're going to do an adaptive toolpath with the shear hog. We'll post the speeds and feeds when it's running, and we're going to do a parallel operation. We'll recreate this at the end again for you guys that want to see, but look, it's just so easy, and it takes 2 hours and 5 minutes. So grab a Snickers or a beer, folks, sit back, relax, enjoy some footage, and at the end we'll go through the Fusion 360, importing the CAD and CAM. Take a look, folks. How awesome. I freaking love this. Just, to me, this is so cool. And this is so cool too. So I had to run home for dinner with my 2-year-old son. And so I turned off our air compressor, but left the lines open in the 80-gallon tank or so. And so coolant ran out. And look how you can see the line and the change in the cut quality in the toolpath when you can literally see it. And this is too funny to me because at the end of chip break 14, I was asking for help. We were helping with that robo drill machine at Zane State College, and we weren't getting a great toolpath. And I think it was actually partially a speeds and feeds question, but a lot of the comments were talking about how coolant really does matter, especially on something like this. And this is actually inadvertently proof of that. So good takeaway there. The other takeaway, folks, is just how awesome is this? This 440, no, it's not a production VMC, but you know what? It's actually a pretty good single lot machine in a production environment for some specific uses, but also look at that shear hog cut. Look at the precision and the quality. I so wish I had had this when I'd started 10 years ago in New York City. Like, this is such a good little machine for stuff like that. And just the overall takeaway, we've been doing some thinking about, what is our YouTube channel about and what are we trying to show? And I want to show that you guys can do this. There isn't anything difficult, or there isn't, months or years of experience that you need to get to make something really cool like this. So I hope you guys enjoyed that. I know it was a little bit different content, if you will, but if you do, I appreciate liking the video with the thumbs up, commenting below, sharing it with your friends. Otherwise, take care, folks. See you next Wednesday. Let's walk through how you can do this. Awesome. So I'm at GrabCAD. I'm going to use this Porsche Carrera 911 body file. There's a link in the video description if you want to follow along and download it. I will click download all files. If you don't have this link, you may need to create or sign into a GrabCAD account, which is free. I'm going to save these right here. Probably going to overwrite, that's fine. Got my zip file, right click. 7-zip is, I like this little 7-zip software. It's a little bit more efficient, free download. Extract here, and I should get an IGES file right here. That's what I want. All right, Fusion 360. See this little upload in the cloud right here? Click that, and I am just going to drag my IGES file right over here. This is 10 megabytes. We don't have great internet here in southeastern Ohio, so I'll be right back. Click close, and here is our new file right here. Double click. Here we go. Oh, now I happen to know that this file is way too big, or the model is too large. So the first thing I'm going to do is change its size, change from the sculpt to the model environment, and I am going to hit R for rectangle, or L for line. How about that? And if I create a line on this plane, all I'm going to do is, I don't really like the measuring in Fusion right now. It's getting better, but by doing a line like this, I can see. I'm actually sorry, guys. I know it's a German vehicle, but I need to switch back to inches. So that's 32 inches right now, and we're going to use a 6 1/4 inch block. So I now have enough information to do this. Go to Modify Scale. What are your entities? Just drag a box around the whole thing. Point doesn't really matter here. It's the point at which it scales bigger or smaller. There's no, again, it's a single object. It doesn't matter. And so I'm going to say, you know what? It's a 6.25 inch long block, but I wanted some cushion. So I'm going to say 5.9 divided by 32 should change that length of the car from the tail to the hood down to 5.9 inches. We'll see here in a second if that did it. Go to Model Cam. First thing we always do, actually I'm going to save my file. That's something you need to do. So it starts auto-saving. New setup. I think our orientation is going to be incorrect here, which is no big deal. It's a good example of how to fix it. So stock, I'm going to change to fixed size box because I'm going to punch in the dimensions. But I'm not even going to punch them in yet because they won't mean anything until I fix my work coordinate system, or the red, green, and blue. And this is one of the most confusing things in Fusion 360. It's actually easy to fix. You just have to obey. So orientation. Instead of inheriting the model orientation, I'm going to say this one, select Z-axis and X-axis. So what's my Z-axis? Well, if I turn on, let's see here, why don't I have an origin? Oh, there it is. I can actually use the origin over here, which is kind of weird because I actually want the Z-axis to be the green one. So if I click on that, it should point my blue arrow up, which is perfect, and I want my X-axis to be the blue one, which is kind of weird, but that's gets me what I want. And that's perfect. Z is pointed toward the sky, and then yellow is forward. And so now that I've got that set correctly, I'll go back into stock, and I'll say 6.25 by 3 by 2.5. That just happens to be the raw material. But for me, there's no reason to cut away all this material in the top. So I want to move the model up relative to where the stock is. And the way you do that is see this model position. Right now it's centering it in the Z, so it's centering it top to bottom or up and down. Change it to offset from top. Now, I don't like that Fusion does this, because what it does is it adds in a value that leaves it in the same space, which is kind of weird because you would think, well, that didn't do anything. But just change this to say 10 thou. And what that's going to do is leave just a 10 thou at the very top of the hood or the roof of the car, which will get decked off. And the rest below here, it makes it easy to hold the part. Click OK. Honestly, folks, the hard part's done. 2 operations: 3D adaptive clearing. Use my shear hog. You guys saw the speeds and feeds in the machining side, and I'm going to walk through how I do this. So first thing I'm going to do, actually, I've got a heights problem on my machine, which you shouldn't have. Click OK. Don't worry about some of these errors and everything. What I want to do is create the operation. That way it saves it, because if I do too many things and then I hit escape by accident, I actually lose everything I did, which is super annoying. So I happen to know I want to change a few things. So let's go ahead. Well, we'll let it see what it comes up with this far. It's pretty cool, right? How it's using the solid model to drive these blue toolpaths. This never gets old for me. One of the things I know it's doing is it's staying inside our stock. And this is something where it's hard for me to tell you why you should know this. It's just, you've just got to learn it. So under this geometry tab, I'm going to do 2 things. I'm going to say machining boundary is none, and I'm going to turn on the stock contours. You're going to see a big change in the toolpath now, which is that it's going to actually come in from the side. In other words, the tool's allowed to go outside of our stock, which is exactly what we want on a part like this. See that? It's going to clean everything up all around. Now I've got to change my heights because that's too much for this tool. So let me go ahead and adjust that recipe a little. I'm going to say maximum step down of 0.2, optimal load of 0.2, and fine step down of 0.03. Let's see what we get. I think this was actually pretty close to the recipe we actually cut with. You'll notice these adaptive strategies, they take a little bit longer to compute because the software behind the scenes is actually creating a solid model, moving the tool a certain distance, looking at what happened to get that constant chip load. It's really amazing from a software standpoint, and it's what gives you such a good toolpath. So that looks much better. I like to do sim a lot, so simulation, I'll click fast forward just to go to the end to see what we get. And we're just roughing stuff out here. Pretty cool. If you wanted smaller stair steps right there, the most important variable that I'd encourage you to focus on is this minimum step down and fine step down. Those are the 2 big ones there. Now all you got to do, God, this is amazing. 3D adapt or 3D parallel. I'm going to pick a ball end mill, tool 40 for us. And I'm going to change the step over to say, just for the example here, 5 thou. I think we actually ran it smaller than that on camera. And it's interesting, even though this parallel operation is really complex, it's much faster to generate because it doesn't have to do the iteration. So look, just like that, we get this beautiful toolpath that's hugging every little surface nook and cranny with that ball end mill just perfectly. So that's it, folks. That took me 9 minutes to show you on video. Most of the time was downloading and importing the file. Creating these 2 toolpaths is just awesome to me. We can click Setup, Sim, and jump to the end here, and you'll get a chance here to see what it thinks it's going to look like in a second. We'll have this Fusion 360 file available to download on our Patreon page. Patreon is a way to support our channel and what we do as little as $1 a month. We really appreciate the folks that sponsor us and help us there. Here we go. It's coming along. Don't rely too much on the simulation. It's funny. I just said it's a great tool, and it is, but the graphics here aren't going to be render quality graphics. You also sometimes want to turn. See up here in the top left, this little light bulb that my mouse is over. By turning that off, I remove the solid model behind it. Gives you a better sense of what it's actually machining away. So that's it, folks. I hope you guys enjoyed that sort of how-to. It's really cool to me that we live in a world where we've got this hardware and the software and the ways to make things like this. Really is pretty cool. Anyways, with that, take care. I'll see you soon.